In this video, we'll be developing and deploying a cloud-native AI detection application built for the edge. We're going to walk through why do we want to use the edge. We'll then walk through some training and how do we train our model using Vertex AI up in the cloud. And then we'll follow up by actually running the inferencing at that edge. To start off, my name is Mike Ensor, and I'm a tech lead for Google's distributed cloud edge. So let's first start talking about why the edge. Why not just use the cloud for everything? We need to kind of recognize that there's compute that happens across a continuum. Up in the cloud, we have hyperconversion. We're able to elastically scale based off of the demand and the need that we have for our applications. However, there's one flaw. We have things that are at a local area network that are prevented from reaching up to the cloud or even interacting with the cloud. If you have a few locations, VPNs tend to make sense. If you've got thousands of locations, you all of a sudden now have a problem. So we can now move down to what's called the GDC local edge or the local zone. And what this is, it allows us to create a hyperconverged compute that happens at a major geographical region. Maybe call it like a city or a region within a city. But we still have the same constraints. We still can't reach down into that local area network and work directly. So then the last continuum we talk about here is the consumer edge. And this is where we create compute and work on compute that happens inside the local area network. With that being said, we still want to take a cloud first mentality. Having something at the local edge doesn't mean that you have unlimited space and unlimited capacity. It's expensive to continue to keep vertically scaling, so we need to have leverage the cloud where possible. So in order to do that, we come up with a good common flow chart. First thing we think about is, do I need to make a decision that's less than 100 milliseconds? Keeping in mind that the amount of bandwidth that I need to push up to the cloud to make the decision and then bring that decision back down, is that less than 100 milliseconds? Do I work with unstable networks or do I have networks that are intermittent? Maybe I have a small bandwidth and I can't work well with that. It's a great candidate for being an edge. Next, we think about large contextual data. When I push this all up to a cloud, is the first thing I do is just aggregate it or maybe cut down the fidelity of the data and then just make the decision on that? If so, why push all the data up? Why not make the decision local? Last bit we think about is with the data privacy. Anytime you're dealing with a human or using personally identifiable information, that information generally can't leave the location and most often can't leave the region. And so it's a great candidate for being an edge solution. So in this talk, we're going to walk through what it means to make an AI that's deployed on an edge. First thing we're going to do is we're going to get in and set up our GDC clusters. This video is not an introductory course on GDCE, so we're going to be introducing just the core concepts that are necessary to achieve the tasks that we need to do for deploying this application. Next, we're going to train a model. We're going to use a predefined data set of a whole bunch of people wearing hats, and so that way we're able to do the inferencing from that. Again, this is not an introductory for Vertex AI, so we're going to be doing just the minimally required task in order to achieve the goal we want to have. Last, we're going to use several of the Google product tools like config sync, and we're going to use that to distribute our functionality and do our compute down at that local area. And we'll follow up by demonstrating what the solution looks like by actually running the demonstration. So the way that we structure this all together is it kind of looks a lot like this. We're going to start on the left-hand side, and we're going to build a model. We're going to train a model up on the cloud. It's the most economical location to build this. From that process, we will then export that out and drop that into a Google Cloud bucket. At this point, the AI model is essentially done. On the right-hand side now, I'm going to use my config sync to distribute out the configuration for that end location, and it's going to refer back to that Google Cloud bucket. Additionally, it's going to refer to configuration that runs a TensorFlow serving engine. That TensorFlow serving engine is now our endpoint that we run our application to perform the inferencing from. Over time, you can collect information from this inferencing server and send it back up to the cloud to make your applications and your models more efficient. So the first stage, before we get into the demos, we briefly want to describe some of the data model components for GDC Edge. When you get a GDC Edge, or when you've ordered it and it's come to you, you get what's called a edge zone. An edge zone is our way of grouping a series of machines and associating that with a Google Cloud project. Everything below the green line is a Google managed product. So you get 3 or more machines that all compose together into a small rack or a medium or sometimes large rack. And inside of that, you're able to create clusters. You, as the customer, can use APIs, Terraform, and any other APM that or config management that works out there in order to build your cluster. We actually manage that. We have Google SREs who maintain and make sure that those machines are up and functional, and we'll fix them if there's any issues with them. On top of that, though, you are responsible for building the applications. And in our demonstration, we'll be using that concept to build our applications on top of. All right, so let's get started. All right, so the first step we want to do in creating our application is going and creating a Kubernetes cluster on our edge. From our menu, we can select down here and we'll see a new menu item called Edge. Under that, we have the Edge zones. And in our edge zones here, you'll see that we have multiple different zones that have been established already. A zone is often synonymous with a location, but it doesn't have to be. Sometimes you can have multiple clusters that exist at an individual location. In our case, we're going to create a new cluster at this den 13. You can click on our view clusters, and we can take a look at the clusters that already exist. We'll go ahead and create a new cluster. This gives us an opportunity to look to create a cluster anywhere within GCP. However, we're looking for the edge. So we'll go to the on-premise. We'll take a look at the distributed edge cloud edge and click on configure. Let's go ahead and name our cluster. We'll call it Edge 1. We need to know some basic information about how this is deployed inside of the local area network. And so we have an opportunity to change some of our CIDR addresses. So we'll set our CIDR ranges for 2 private ranges. Create an administrator. We'll potentially change, if you want to, you can change and enable a different maintenance window. Select which project this is going to be deployed into. And then from there, we can select the zones that we want to work with. This often takes a moment to populate, especially if you have a lot of clusters. So let's pick the Den 13 that we had selected previously. Click on our pool, and the last setting we have is how many nodes do we want to make our Kubernetes cluster. In this case here, we want to use 3 because we'd like to have a high availability cluster. You can use 1, 3, or anything plus 3 from that point on. With a GDCE computer or node, you must use the entire node for that. Let's go ahead and hit create, and we'll create that cluster. This does take about 15 minutes, and so we are going to use one that has been previously created and move on and look at our model next. All right, in phase 2 now, we're going to go ahead and build a model. So what we'll do is we'll go down to Vertex AI and take a look at our data set. We have previously uploaded multiple different images here of friends, family, all wearing the various different hat that we want to have as our target or as our classifier. Once we have uploaded that, created all of our training data, labeling them, making them ready to go, we'll go ahead and train the model by clicking on training. We have several that have been previously run. And in order to expediency here, we will go ahead and just use the latest training that we have done. Click on that training model. These often can take about 2-3 hours to create. And so we'll use this existing one here. We first do is we go up to export. And we have an option of saying, do we want to export this as a TF Lite, a container, or TensorFlow JS? In our condition, we want to run this as a container. So we're going to pull off the container. We give it a GCS bucket that we want to export it to. Click on the export and allow this to take its time to export. Now that the model's now been created, we can go ahead and move on over to the application. All right, on our application, let's take a look at what we're going to be building here. So we have some Kubernetes clusters that already exist here. We can take a look at those. The Kubernetes cluster Edge 1 is right here. It's located in Stanwood. We've got some compute already on it. Let's go ahead and make our application or make a change to our application and get ready to deploy that to the edge. I'm going to pull up this screen here. This is our editor, and we're able to make some changes. In the latest model, as a contrived example, we want to change the title from inference model to Google Distributed Edge. So that way we better know that this came from a Google Distributed Edge. We can go ahead and make our commit and push that out. Once that, as that's being pushed, we have the opportunity now to go ahead and make that application compiled. We can use gcloud. We can use gcloud builder and build our application and push it to the GCR repository or the repository of our choice. This also takes roughly 5 minutes to build, so we will go ahead and fast forward with an option that has already been created for us using this exact same command. This will give me a moment, though, to talk a little bit about how do we deploy our applications to these edge. I had previously talked about using config sync. Config sync is a GitOps operator that allows us to set a desired state for an end location. What that means is I can fully define what my end state looks like even before I have a cluster. When I associate the cluster with the GitOps operator, it then allows me now to, or allows that cluster to reach out and say, oop, I'm edge one. What does my configuration look like? Inside of this folder structure, we have things like we have our PPE demo, right? So I can pull up the configuration of our PPE demo and take a look here. You'll notice that it is a deployment object. Inside of that deployment, I have a location. Here's the latest version that we have built here. Oops. The latest version of our build here is called V2. So pushing this, making a change here, and pushing this to the cluster allows me now to change the state of that cluster or the desired state. So let's go and take a look at what that has done. So this is our example of the application here. We can now see that it says Google Distributed Edge, whereas it previously was an inferencing server. And let's go ahead and test it out. With this example, you can see that the bounding box is now over the top of my over the top of me, and it has clearly identified that. By looking at the URL structure, you'll see that the URL is a 193.168.3.24. It's an RFC 1918 private IP. This is an application that is doing inferencing at the local edge, yet we've built it from the cloud. So there you have it. I hope you enjoyed walking through building an application, deploying a cloud-based trained model, and pushing it down to an edge. Thank you.